Hello Info-Person, this is Anton, and today we're going to discuss a somewhat interesting follow-up to a really bizarre study we've discussed back in 2020. A study whose goal was to understand the mysterious cosmic web, the enormous structure that seems to stretch through the entire universe, and a structure that potentially is responsible for organizing a lot of galaxies and a lot of gas inside the universe, making everything appear like it's some kind of a spider web or some kind of a tendril. And the evidence for the existence of this web has been discovered in the last decade. But because it's so difficult to detect and because it's practically invisible, researchers have always been trying to find some kind of an effective way to study this web without physically observing it. Mostly to understand how the universe evolved, how galaxies and structures surrounding galaxies grew over time, and how the gas in these galaxies propagated as well. And even though we can technically see the galaxies and can sometimes detect gas here, because the web itself is mostly made out of invisible dark matter, it's just a little bit too diffuse to be detectable by any physical means. But if you actually want to learn about the few times scientists were able to see this web, check out some of the videos in the description. And so in order to study this, a team of scientists was able to invent something really clever. And it's actually based on previous studies using various mathematical algorithms through the use of a biological organism. And it's basically this, sometimes referred to as the blob. It's an organism known as the slime mold that we've discussed on the channel previously because of its unusual ability to essentially create these very bizarre structures, and also because it's technically a superorganism, even though it's formed by individual unicellular protists. And as you can see, it's just really good at forming various types of networks. So good, as a matter of fact, that it's been previously used to solve the shortest path problem, a type of a mathematical problem where you literally have to find the shortest and the most efficient path between several points. But in this case, it's able to solve really complicated transportation problems, even recreating some of the most famous cities like Tokyo, Paris, and Barcelona. And so, for example, for Tokyo, which is one of the most complex and technically the largest city on the planet, by placing food pieces representing main locations in Tokyo, the slime mold then recreated a filamental structure that seems to be practically identical to the Tokyo subway in just a few hours. And that by itself back then was quite incredible, but also presented us with a really interesting way to solve a lot of mathematical and even physical problems through the use of this unusual organism. In this case, this slime mold is known as Physarum polycephalum. Here's what it actually looks like in nature, and because it's so widespread, you might have actually seen it before in real life. But over time, to make things even easier, and I guess to some extent more efficient, instead of using the actual slime mold, researchers developed an algorithm that's able to mimic this mold pretty much directly. And one of the newest such models is known as Monte Carlo Physarum machine. One of the studies in the description describes this a little bit better, but in essence it's an algorithm that can easily mimic the activity of this mold by following the same procedure. In this case, you basically introduce these food-like particles, and it then grows the network in an extremely similar fashion. And so back in 2020, using this algorithm, the scientists were able to recreate the cosmic web. And they did this by using the galaxy surveys and using individual galaxies, and specifically some of the more massive galactic clusters, as those virtual food particles that would then cause the mold to follow certain pathways and to create a certain network. And intriguingly enough, it was super accurate at representing the mysterious cosmic web. It was easily able to trace the dark matter, in the process also allowing the scientists to discover a certain feature of the cosmic web we could never physically see. For example, these models confirm that most of the intergalactic matter seems to be indeed present inside the cosmic web, with only some matter present in between these unusual tendrils. And this has been confirmed in the last few years using various observations, with further confirmation coming from the observations of various distant quasars that were able to reveal both the location of galaxies and the location of different types of gas. But in this new study, they combined this algorithm with some of the more complex simulations involving galactic formation. For example, the famous TNG 100 created by the Illustris project. And here once again, these simulations were able to reveal something we never knew before, helping us uncover certain mysteries of the universe. Now, as always, you can find all of these studies in the description below, But in essence, the main point of this study was to try to see how everything changed in the last few billions of years and how the evolution of galaxies was affected by the cosmic web itself. And well, here's what the scientists discovered. Just like before, they discovered that over 90% of all galaxies seem to be located within about 4 million light years of a typical cosmic web filament, with only some galaxies located in between the galactic filament in these so-called galactic voids. And you can learn about some of these voids in one of the videos in the description. But one of the strangest discoveries here was in regards to galaxies in the first few billions of years. So here we're talking about a redshift of over 1. This is in the first 6 billion years right after the Big Bang. And it looks like no matter where these galaxies were located, so basically inside or outside of the filament, they seem to be forming stars relatively similarly. In other words, the proximity to the cosmic web or the amount of gas around the filament did not affect galactic evolution very much. But that was in the first 6 billion years. After this, so basically redshift of less than 1, things started to change quite dramatically. And a lot of this material that was pulled into the web eventually started to disrupt star formation, especially if the galaxies were just a little bit too close. And so many different galaxies in the much older universe became extremely gas poor and essentially quenched or would not produce any more stars in very high density environments near the center of these filaments. And that means that if the galaxy was basically in the center of the cosmic web and it was older than 6 billion years old, it would be extremely likely to be essentially dead, no longer producing stars, no longer producing anything new. And moreover, this seemed to have even more effect on various galactic satellites. So even though the more massive galaxy might not be as affected, a lot of its satellites would most likely stop star formation if all of them were inside the center of the cosmic web. And so essentially this particular study discovers that the galactic location inside the cosmic web seems to have dramatically influenced the evolution of these galaxies in the much more recent universe. With galaxies in much denser environments, or basically in the center of the cosmic web filament, and galaxies surrounded by a lot of gas and a lot of mass, more likely to be completely dead, completely inactive, and basically not doing anything. Whereas galaxies slightly on the outskirts, or possibly in between galactic filament, were more likely to be still active and still producing stars. And interestingly enough, this was actually one of the mysteries we've discussed in one of the videos of these so-called void galaxies. Galaxies that have been discovered in these galactic voids, so essentially between the filaments, with 6 famous galaxies in a nearby local void that surprisingly are all active and all producing stars. And this potentially explains why, or at least presents us with the explanation that doesn't currently break any models. But naturally, these types of studies would still have to have actual physical evidence and physical observation to confirm all of this. Mostly because these are still just models, and in this case computer models, even though they're based on an actual physical organism that seems to be able to recreate various physical networks super well. I mean, honestly, when I just heard about this was super mind-blowing, and I'm pretty sure many people couldn't actually believe this at first. But just the fact that the slime mold here is able to recreate these networks, and is thus, by extension, can actually help us recreate much bigger networks, such as the cosmic web, turns this into a kind of a multidisciplinary study that joins the realms of biology with the realm of computer science, algorithms, and of course cosmology. And so far, all of the results from these studies have been super interesting, and more importantly, have been kind of proven to be correct in the last 4 years. But whether these new discoveries are correct as well, only time will tell. And so we're definitely going to come back and talk more about this once there are some additional discoveries, or once there are some additional super cool models. I mean, the slime mold by itself is just so bizarre and so unusual that it's worth talking about it every single time there is some kind of a new study. Which of course means that we'll come back and talk more about this in some of the future videos. Until then, thank you for watching, subscribe, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, support this channel on Patreon by joining channel membership or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.